Hello everyone. In this lesson, we're going to take a look at coordinate proofs of rectangles, rhombuses, and squares. All right. So this is also a snippet from Mr. Burke's graphic organizer, which again, I will post the full graphic organizer in Google Classroom along with all this other material, so don't worry about that. But okay, so we're taking a look at rectangles, rhombuses, and squares. And the rectangle and the rhombus are down here on this second level here. And I want you to notice that the first step for both of these guys is you must prove that it is a parallelogram. So that's going to be your first step every single time is to do this top part. Oops, I'm writing in white. Step number one. Always got to prove that it is a parallelogram first. And then we get into choosing one of the following for a rectangle, let's say. So for a rectangle, you can either choose to show the diagonals are congruent, which is again two distance formulas, or you show that there is one right angle, which is going to be slopes. So for this one, you would need to write a sentence such as consecutive sides are perpendicular. That's what you would write for that. Consecutive sides are perpendicular, therefore it is a rectangle. Okay, now let's move over to the rhombus, which is over here on the right-hand side. So again, prove that it's a parallelogram first, and then choose one of these guys. So one pair of consecutive sides are congruent. So that's the distance formula. Remember that, distance proves congruence. So that's two equations right there. And then the diagonals are perpendicular this time. So again, that's slope. So for both of the rectangle and the rhombus over here, it's a push on the work. You either choose to do two equations here, which are distance formulas, or two equations of slope, either one. So it doesn't matter which one you choose, it's the same amount of work. Now that is different for when we go down here to the square all the way at the bottom. The square encompasses everything. So if you see here, the first thing you gotta do, always parallelogram. Then you gotta prove that it's a rhombus. And then you gotta prove that it's a rectangle. So a square is all of those things at the same time. So this is a three-step process. Prove it's a parallelogram, then a rhombus, then a rectangle. Okay, so let's just jump right into an example here. So we are given quadrilateral walk with points of those, and we need to prove that walk is a rectangle. So let's just go scroll back up here for a second. We are proving a rectangle. So first thing we need to do is show that it's a parallelogram, and then we need to choose one of these guys over here. I'm going to go with diagonals are going to be congruent. I like the distance formula personally myself. So the first thing we got to do is prove that it is a parallelogram. I'm just going to zoom in here so that I have enough room to work here. All right, so when step one is we need to prove parallelogram. Prove parallelogram. Which remember, that's two distance formulas for the diagonals. So my midpoint formulas, excuse me, not distance, midpoint formulas. So the midpoint of WL is going to be, and again, I like to label my points here. So I'm going to go ahead and do so. This is my x1, y1. This is my x2 and y2. So for WL, I have -5 plus 5 divided by 2. And then I have 0 plus 2 divided by 2, which gives me a midpoint of -5 plus 5 is 0, so that's 0. 0 plus 2 is 2, divided by 2 is 1. There we go. And now I'm going to do my second midpoint for my other diagonal. which is AK. So AK, and again, I'm going to label my points here. So this is x1, y1. This is x2 and y2. So I got 1 minus 1 divided by 2, and I have negative 4 plus 6 divided by 2. And this gives me a midpoint of 1 minus 1 is 0, so that is 0. Negative 4 plus 6 is positive 2 divided by 2 is 1. Excellent. I have the same midpoint. Okay, so now all I got to do is write my sentences for what I just did. Oh, keep the same color. There we go. So, quadrilateral WALK has diagonals that bisect each other. Therefore, quadrilateral WALK is a parallelogram. All right, now we move on to step number 2. No, I want to write. There we go. Step number 2 is now we need to prove that it's a rectangle. Prove rectangle. Let's just remind ourselves what we need to do for rectangle. We need to choose either between diagonals are congruent or that there is a right angle. I'm going to choose to do that the diagonals are congruent just because I like the distance formula for some reason. Don't ask me why, but I do. So the distance of my first diagonal, which is WL, is equal to, well, if you recall, our distance formula is x2 minus x1, that value squared, plus y2 minus y1, and that value squared. And all of that is underneath the radical. So my x2 for my diagonal, which is in red up here, is 5, and I'm subtracting a negative 5. So I'm going to do 5, subtract, I'm going to put that negative 5 in parentheses, just so that I can see that I am subtracting a negative, and that value is squared. And my y values are going to be 2 is my y2, subtract 0. So I got 2, subtract 0, and that value is squared, all underneath the radical. So this gives me a distance of 5 minus a negative 5, that turns into 5 plus 5, which is 10. 10 squared is 100. 100. 2 minus 0 is 2. 2 squared is 4, which gives me a distance of radical 104. All right, now we got to see if the other diagonal shares that same distance. So let's do this guy in blue. So our other diagonal is AK. This one, I'm just going to substitute in. So my x2 is negative 1, and I am subtracting 1. That value squared, plus my y's are 6 minus a negative 4. 6 minus a negative 4. That value is squared as well. So negative 1 minus 1 is negative 2. Negative 2 squared is 4. And then we have 6 minus a negative 4, which turns into 6 plus 4. That's 10. 10 squared is 100. Beautiful. And this also turns into a distance of radical 1 over 4. Perfect. Now all we have to do is just write in our sentences. So, quadrilateral WALK has congruent diagonals, therefore WALK is a rectangle. And that's it. So the process for doing these proofs is you must show that it is a parallelogram first, and then you go to your list and you either prove that it's a rectangle and you choose one of those, or you choose, if it's asking for you to do a rhombus, you must choose one of those things to prove that it is a rhombus. Now, the last thing about physically writing these things is that you can choose to write these two or these four sentences here. You can choose to write those things as one paragraph if you want to. I chose to split these guys up and then I was done right here. But if you want to take this stuff up here and just attach it to the top of this as one paragraph, you can go ahead. That is your choice. It does not matter. Okay? All right, that's it for this lesson. As always, be safe and be healthy, and I will see you guys next time. Bye.